But this week, however, I'm going to see how far I can get building a transfer learning model. For those of you who aren't aware, a transfer learning model is where you take a neural network that someone else has built for some purpose, maybe you built it yourself, for something. You just say, give me this part of the network, including the weights, and I'm going to change this other part of the network and learn new weights, or maybe also adjust the weights that you've given me. And so the idea is you can use the learning that someone has already done on a lot of data and just fine-tune it to whatever your data set is. So I want to do that with the self-driving car model to interpret the webcam images properly. You might be aware of a large number of image classification models that are out there. Have you heard of like ImageNet or stuff like this? They're very good at classifying like 1 of 1,000 classes in terms of images. Excuse me. There's another one called SqueezeNet that it also gets very good accuracy, and it has a very small model size. It like fits in 5 megabytes or half a megabyte or something. This fellow has created a Keras implementation of that, and so I forked his repository, and I've got that on my repo list now, and I'm going to fiddle with this. I want to take this SqueezeNet and make it sort of the top part of my network. Whereas if I say autonomous, you might recall auto has the model. It's just doing a couple convolutional things. There's like 3 layers. So there's probably going to be a lot more going on, but hopefully we won't have to train that too much. It will already have sorted itself out. That's the idea anyway, that you will have already trained your model to extract some interesting features based on the transfer learning model, and then you sort of drop into your normal model, fine-tune those a little bit, and sort out the rest. So this lets you get away with having much less data, which whatever I'm going to do with this model, I'm going to have less data. That is just the reality of the situation, of the hardware I have available, the actual data I have available, how much time I'm willing to spend on this whole project. So if I can get the transfer learning to work, we're sort of going to replace these 3 layers that I have to train myself with maybe one of these SqueezeNet models, which it looks very compact here when you do this get SqueezeNet, but the architecture of SqueezeNet is kind of funny. It uses these things called fire modules, which I'm not going to go into a whole lot. It uses sort of 2 simultaneous convolutions to get some... It splits off and then joins back together, and it does that several times. That's at a very, very high level what the fire module is doing. But that's the idea anyway. The catch here is I understand all the concepts. Those aren't too bad. How do we actually get this to work in code? As always, you need to extract the actual weights from the real SqueezeNet model. So I've downloaded the actual SqueezeNet model. Model files sqn weights.h5. It's actually part of this repository, I think, which is bad. You should not put binary files in the repository, but whatever. It's only 5 megabytes. Who cares? Yeah. If you fork that repository, fork it from the original guy, if you can, and then you'll have the weights. I think that's the 5 megabyte version. So it's not the super smallest, but that's okay. 5 megabytes is plenty small for what we want to do. So I've got that file. It's an HDF5 file format, so you open it up here with W. If you want to look at something, it's got W graph is sort of the object. You say, oh, well, I want to know what the keys are, and of course you get this unhelpful view. So you call list on that, and you just get param 0 through I think 52. So that's not super informative in terms of what you get. But I said, all right, I'll just grab all of them. So I just made up a new list, and I started stuffing NumPy arrays in there by just formatting as I went along. So now I've got this all W thing. All the weights from the SqueezeNet model are mine. They belong to me now. So you can nominally, excuse me, oh my goodness. You can nominally say whatever your model is. I've created the SqueezeNet model right here. I've made some very minor alterations to use more updated code, but other than that, it's the base SqueezeNet. And you can say, oh, I've got a 10 by 10 image, and I said, oh, I've got a 64 by, or sorry, I've got a 10 image classes. So imagine if it was SciFar 10, the classic image recognition benchmark, and suppose I want my image to be, oh, I don't know, 64 by 64, which happens to be the size of my images in the self-driving car model. But that could be whatever it's going to be. Because they're convolutional layers, almost all these, you can get away with doing this. You still have the same weights. I still have the same weight matrices going in, I'm going to be applying it to a larger or smaller image, depending. So the computational time will go up or go down, but hopefully the number of parameters should not change, is the idea. Anyway, you get the M, you could say m.setWeights. That lets you set the weights of the model, which you would think is great. That's exactly what you want. I'm not convinced that this is working the way I want it to, though. Let me fetch a new... So I got a new model. You can get the weights as well, of course. Let me just look. It gives you a list of NumPy arrays. Let me just grab the first one. Let's just call that little w NumPy array 96, 3, 7, 7. So there's 96 filters that are of shape 3 by 7 by 7. So 3 colors, red, green, blue, and they're 7 by 7. So they're fairly large convolutional filters. Whereas if I were to look at all w of 0, the first parameter, and ask what the shape is, it actually matches. So that's good. Actually, that's just what I should do. I should just go through and compare all of those shapes. So let's do that. Compare shapes. And yeah, whatever. For I in range 52, I guess. Sure. I don't need the model file anymore because I've already gotten all those, so I'll just reuse W. I'm a horrible person, that's okay. And dot get weights. Just like that. That's all you gotta do. And then I want to say wi dot shape. Let me just print it out here. No, here we go. If, sometimes you just have to nuke it. If w of I dot shape equals all w of I dot shape, rather if this is not true, then print, I want to print I don't want to print this stuff, I want everything. There we go. Let's get that. Just so we can do some inevitable debugging that will happen with this. Because I just want to use most of the layers of SqueezeNet, not all of them. So let's see what happens. Okay, so there's actually only a few places it goes off. So obviously, this last layer, there's nothing we can do about that because the true SqueezeNet model says I've got 1,000 images I'm trying to classify. In the magical SqueezeNet model I've created here, I said I've only had 10. So this last layer is just a bias term. The one before that is sort of like the final dense layer. It uses this global average pooling in the model itself. That's one of the things that I updated. They sort of had to hack in the global average pooling before, but we've got that now. That's in part of Keras. It's nice. You can sort of think of it as a final dense layer. It's not exactly. In fact, no, it's not, because that's this. It's acting like it. It's this convolution, which is 512 channels of 1x1 convolutions. So sort that out. But where does it goes off in the middle here. 22, 23, 24, 26, 25, 26, which is weird. That throws me for a loop. There's a 192 versus a 128. This business? Perhaps? I would think that's what they're getting at. Then there's a pool size. So the question is, the one on the left is my actual model weights. The one on the right is the squeeze net shape. Sorry, not the squeeze net shape. The squeeze net weights themselves. So it looks like I've got two 192s that should be 128s. So I'm going to go ahead and try, and it's a 32 and a 32. I already see a problem here. Oh no, these are the two fire models right here. That's why it looks like there's two things when there's only not. So I think this is 128. So let's see what happens, shall we? Maybe there was this is like a typo, or maybe I'm misunderstanding things. All these things are possibilities. Do that. And recompute that. Yes. Okay, so now it's just these last two layers that are sort of all mixed up, and that's okay. This is working better than I would have thought. So you want to use m.set weights. Sets the weights of the model. Weights are must be listed in NumPy arrays with shapes and types matching the output of model.getWeights. Okay. What if it's not? See, that's the thing. I bet I could say model.setWeights all W, which is a list of NumPy arrays, and it doesn't yell at me. And my question is, why doesn't it yell at me? Can I pass in an empty list? Will it argue at me then? No. That's totally fine with that. Model.getWeights. Alright, let's reset the model. And let's reset this. And let's redo m.setWeights again of all W. Yep. m.getWeights equals W? Yeah, not something we can do. W0 m.getWeights 0. Let's take a look at that. Those are different numbers. That's actually interesting. Okay. -1? Does it just not set the final? -2? Those are the same. Oh my gosh, it's actually pretty smart. It just doesn't set the layer weights if it gets the wrong thing. Huh. That's actually really cool. Okay, this might actually work better than I thought then. So we've set all the squeeze net stuff, I think. Let me double check. Yeah, that's one. Yeah, okay, wow. I thought this was going to be a huge pain in the butt to get working, but this actually worked much, much better. Okay, in that case, so now that SqueezeNet is sort of working, now I want to make this work with auto, and I think I'm going to go back to using the deep drive data for now, just because I was a little more comfortable with that. I felt that had a better variety of like turns, especially. The comma AI data I happened to be looking at was just a lot of highway driving. Okay, wow, I fully expected this to take an entire evening, but it just took 15 minutes of, dedicated effort. Make dir trans. So we're going to make a transfer model here. Go into trans, and I'm going to copy proj/squeezenet trans. Drop that off here. Likewise, model files. UN weights. There we go. Drop that off here too. Alright, I prefer to work in my autonomous directory here. Trans. There we go. Much better. Okay. So that's just some test stuff. And this is no longer going to be this. So that's fine. It's actually immaterial what this final business is. I don't really care about that at all. In fact, I don't even really need to get a SqueezeNet model. I just need to load in the weights. I don't need the... Oh... I do need to make my own SqueezeNet-like model, though. So not get SqueezeNet, get SqueezeNet trans. There we go. And what we're really doing now is we're going to be looking at auto. We want to grab whatever model I have for him, which... Oh, I didn't even tell you guys about this past weekend was New York Maker Faire, and we brought Otto out there just as like a demo. He did okay. I was stressing that he still has his learner's permit, is the nature of what he's up to. But we got to like diagnose and debug a lot of the issues he was having, and some of the trouble is related to the model is saying do this, but the steering is not responding quite correctly. We're having a hard time communicating still between the actual model and what's getting communicated. All right, so that's doing the global pooling. So I think if I flatten that out, that should be what I want. And that will be good. And this is autonomous. Auto takes over. Auto takes over right here. There we go. Let's do the real input as well. Make sure we get that. Although I don't know if I'm really going to be continuing to use this information. Like I don't feel like I'm computing the speed correctly in the actual autonomous model, since we just have the acceleration over time, and I can sort of compute that, but I don't know how correct that is, which is always going to be trouble. Real in and frame in. Input image? Is that what I want? Input shape and rows and cols. Yes. Input shape. Input image is the magic here. Input image. There we go. So that could be the model. Yeah, like that. That. I could already have compiled it or whatever. That's fine. I think that's actually right then. So let's see what happens. People stop being polite. Jeez, this just says so much garbage. There we go. Just go fast enough is what Brian says. You know, we amped the speed up over the weekend too. It turns out we were only going like 1/5 of the maximum speed. But the wheels on this vehicle are made of plastic, not like rubber, air. So we ended up just sliding all over the pavement when we tried that. We also introduced a couple fail-safe measures for when you run into a wall, which will happen and did happen several times. And that's when we discovered the problems with trying to get it to steer correctly. Alright, get SqueezeNet trans. That's what I want. Did I call it correctly? Yeah, I gotta rename the variable, do all this jazz, didn't name it right. Trans. Bam. There we go. Okay. Oh, this is... Oh, what'd I do? What'd I do? Okay. Thought I screwed something up here. Let's do this. Make sure I have that. Is auto indent correctly set? Did I miss that? Oh, I did miss that. Guys didn't call me out on that. There we go. Yeah, so the car actually, it ran, it went forward, it tried to turn sometimes. It was in an environment that was totally different than anything it had ever seen. And it didn't receive that much training to begin with. So I was not surprised to see the vehicle run into the wall several times. That said, other people's cars, there were a few other autonomous cars there. I don't know how they all worked. I think one had a LiDAR system, and it had to continually like turn left, turn right, turn left, turn right to like scan the whole area. Wrap jumbo rubber bands around the plastic wheels. That's actually not a bad idea. Thanks to Brian. That's something I've seen before in like some high school project. We created wheels by using old AOL CDs and wrapping them in rubber. Oh, this is a class I can't have either. Oop, that class is gone now. I don't have any classes, so that's just gone. Boom, gone. No more. Doesn't exist. Which means this cannot exist. Works for me. That's how easy it is. Transfer learning. Layer doesn't do what you want, it's gone. Doesn't make any sense, it's gone. L1 is not defined. Oh, right, because I'm doing funky stuff now. Oh, I'm just not pulling those things out. There we go. Need to do that. What else might I need? Might need me some metrics. Might need me some categorical. I have the right optimizers. So I need those. I actually don't need the global convolutional pooling anymore. Oh, I'm gonna need the wacky ELU again. All this stuff is stuff I'm gonna need. Sequential, model, dense, drop, activation, flatten, reshape. You know, I need all these things. I need this. I already have convolution, I'm sure. When do I use K? I don't. Figures. Figures. Alright, if we can get a model that does something, as always, that's like always my goal. Get a model that does something, anything, I don't care what. And that is done this transfer learning, then I call that a win. That is to me a success tonight. Even if we don't, the fact that in principle this can work, that I can take the weights trained in something and just jam it in something else. And Karis just says, I'll ignore the weights that don't matter, that don't match. That's good. I'm a fan of that. That's a big win. Okay, WR is not defined, right? Because that's in here. That's this stuff. Yeah. Facts. Let me set up some globals like a horrible person that I am. That's fine. Let me define these. Can I get away with? I'm betting I can't do that. I don't think Python will let me do that. Oh, it does! Ha! It references the global after I define it. That's new. Okay. Definitely didn't think I could get away with that. Definitely did not think I could do that. That's wild. And rows and calls. I should probably move these. Maybe move these into a different script or library, whatever. But yeah, it's fine. Everything's fine. This is fine. NumPy. Got ourselves some weights. Got that. Let's have a look-see at that. Yeah, that's still there. Let's grab all of them. Yoink. Alright, now then. W dot. How many of these do we have? 56. So we have a few more, which is fine. I want to know, when do they not match? I already grabbed that. And the answer is the last two layers. Okay, something here is not... Oh, I'm only doing range 52. I see, I see. Not the last two layers. But at the end of these fire module layers is where it stops matching. I'm actually surprised. Like, I got rid of layers. I got rid of like 2 layers here. Unless there happened to be no... Oh, this was just 0 padding. And then there was some global pooling. So there might not have been parameters associated with those layers. That might be what it is. Okay. So maybe we can get away with this. Maybe. Just maybe. So I don't need the last 2 layers. So what happens if I say m dot set weights? First of all, what is W0? Just so I'm aware. Dot shape versus all W0 dot shape. That matches up. Yep. All W. Go everything up to -2. Don't bother giving me those last 2 weights. I know they're garbage. I just don't even try. Don't even. And it does not yell. This blows my mind that it does not yell at me. I fully expect it to be yelled at and to need to like pass in dummy weights or do something else to get that to work. This is incredible. Francois Cholet, excellent work on Keras, I gotta say. That's super good that it does the right thing. It sets the ones that it can and does not mess with the ones that it can't. That is incredible. Absolutely incredible. And if I say m.getWeights, last one. Oh look, let's look at number 2. Might be a little more interesting. The same things. Excellent. I believe that means we are in business. And it's time to steal some training code from Simple Steer. And I'm going to edit it anyway, because I'm a terrible person. So, I think I can get away with just doing something like this. We might actually do this ahead of schedule. Ahead of schedule. On time and on budget. That's what they say. It's going to be on budget. Will it be on time? We'll see. We don't need 100 epics. No, we don't need that anymore. Mini epic is 1 now. Alright, let's see if I can do this. Bam, bam, bam. Sorcery. This needs to be M. This needs to be transfer. So we're going to name this business. And we're going to learn what I forgot to import. For example, import from TQDM. Import TQDM. Gotta have a progress bar. That's very important to me. Start off at 0 there. Epic divided by minute. Yes, there's 10 steps. Okay. That's all good. Looking fine. We're good. Okay. Everything's fine here. Batch size, mini epic, verbose, validation split, shuffle, targets. Yeah, it'll look pretty good, I think. Let's see what happens. See if this does something or blows up in my face. So in this case, I am willing to change some of the values in the squeeze net part of the model. That might not necessarily be something you want to do. That was actually pretty dumb. Why did I? That is not something I should have TQDM'd. Because I'm going to get information from the verbose Keras fitting. But it takes a long freaking time to compile the model because it's a large model. It's going to take a lot longer to actually set up. So every epic is going to take a lot longer. We're working on the order of... I actually didn't look at how many parameters this model had. I should have. I guess we'll get to that. Also, we'll see if this like crashes my computer or something. If the stream dies like it did last week, then you'll know that's what happened. So in the Keras documentation, there is sort of an example of transfer learning, but this, let's see, what does it do? It is actually, it's the exact same shape from one model to the next is how it works. It says train a model to fit the first 5 digits in MNIST, then you freeze the convolutional layers, and you sort of retrain the last layer for the last 5 digits of MNIST. So 0 through 4, and then 5 through 9. So that's exactly the same shape. If you trained it on, say, the first 4 or first 5, and then you tried to fit the last 10, that would be different. That would be something new. I want to see, how do I freeze a layer? That's what I want to know. Classification layers, feature layers, define group layers, feature, convolutions, and classifications dense. Okay. Feature layers plus classification layers. So this is just a style of business. Model, NP classes. LDOT trainable false. Okay, so that's weird. So you have to set it for each element, each layer. You have to say that it is or is not trainable. Aha, it's going. And one epoch is now going to take about 5 minutes. And it's cranking quite a bit here, trying to get this going. So that's going to take a little bit of time. It might be faster if I, for example, if I froze those convolutional layers. Then at least I don't have to compute the back propagation all the way in there to figure out what those are. But I still have to do all these convolutional computations. So there's no getting away from it. What might be faster, what might be the best thing, it might be even a better idea, is not try to use the entire SqueezeNet model. So it's got all these fire module things, and by the time you get to the end, you're sort of computing very high-level features about whatever this 1,000 class classification problem was. So these lower-level features might be kind of similar to like the actual images you're trying to find, like the image of a particular kind of dog or something. So I might not want that. I might want the layer much further up, where you're just finding triangles or circles or sort of mid-level features that I can still use to compute something interesting in this self-driving car data set. But I want to see in one epoch how much damage can we do. I'll let it train one epoch, see what happens. Now's a good time to open up questions. I'm just glad I have this. This transfer warning is, in theory, the mechanics of it are working now. That's what I wanted to see happen. So, and again, that's because in Keras it was made so easy. As long as I put my layers in the right order, everything goes well. And we checked the sizes of everything, so that should be good to go. Oh, that's just good. I feel like things rarely work out that well. So we might end early tonight just because sitting here watching this bar fill up, while better than not watching a bar fill up, is not that exciting. I'll probably let this do one epoch, then I'll try taking out half of these models or half of these layers or something. In fact, let me do that. Let me do that right now. Not get SqueezeNet trans, get SqueezeNet mini. Trans mini, mini trans, mini trans. There we go. And I don't know, let's cut it off up here. Why up here? Totally arbitrary. Totally 100% arbitrary. Not gonna lie. It's called a gut feeling. I could do the Google Deep Dream thing, where they look at particular layers and they see what they generate. See if that's what this is. No, this is somebody's website that's very similar to that, but is not the same thing. This is code example for visualizing neural networks. Yes. They are, well, that's not exactly the same either. They have an IPython notebook for it. But this is all in Cafe, which you might recall from one of my previous videos did not work well at all for me. I wonder if there's a Keras deep tree. Oh, hey, what do you know? Actually, it's in... Bam! It's in default in Keras. That's so good. It's just built into the examples. That is so cool. That's just... Oh, good documentation. Examples. I like that. That makes me so happy. But... Bad trip. Dreamy. This is for, like, futzing around with an image. It wasn't exactly what I wanted. Oh well. But you can sort of see what a particular layer is trying to generate. Sort of. Woo! There we go. Alright, we have 1 minute left. I can yak for 1 minute, and surely that can be a productive use of time. So far, this isn't producing super duper awesome. The loss, you might notice, is like 0.08 or so, whereas we were getting like 0.03, or with Isaac's model, it was like 0.02. So there's room for improvement. The one thing to note about this is it does take color image, so we do sort of want to keep that around in our model. I'll let this go 1 epoch just to see how it works, and then I'll try the mini model and see how that goes. 15 seconds, we're almost there. Ugh, this is miserable. Hoping to save a lot of the computation time by cutting down. On the other hand, we'll have fewer poolings, so our interior model size is actually going to be a little larger. And then we'll do the flattening and do this other stuff. So it could be trouble. Could be trouble. It's got to compute now the validation accuracies and everything, which is 10% of the data. So that's going to take 10% of the time. It took 5 minutes, so that's another 30 seconds. Name model is not defined. What? Oh, well, that's because it's called ham. There we go. There we go. Wow. The validation loss is actually pretty good. Better than I expected. Alright, well, that's interesting. I did not expect that. Where's my model? There we go. So, get SqueezeNet mini-trans. Mini-trans, yes, there we go. And we gotta set the weights. Gotta do that again. I have to define my actual function, as always. Things I forget every time. Mini SqueezeNet also fits on the screen, whereas regular SqueezeNet does not. Things that are important when you're streaming. Okay. Make that, set the weights. Objects too deep for desired array. Interesting. Oh, I need a new... No. M dot... Hang on. M dot get weights. How many weights do I have? Is that the problem? I got too many weights? Yeah. Let's have a look-see here. See what matches up. It's gonna yell at me, yeah. Okay. So it looks like up to 20. We are good to go. But after that is when we cut out. So we just come here, do that. Sorcery, it's amazing. Look at that. And we could make that trainable or not trainable. I'm gonna comment these lines out for the moment. And I would do that in the actual function itself, of course. Let's just do this again. I just really want to see how long does this take. That's what's in it for me. Mini transfer, we'll call it. And of course, we have to compile this new model. That takes time. First 80% takes 80% of the time. The last 20% takes the other 80% of the time. Yeah, I'd say that's an accurate statement about what happens. All right, so we dropped from about 330 seconds to 200 seconds. So that did drop and save us some training time at least. So that's an improvement. I think we're probably going to let this finish to see how it goes. Like, does the air change appreciably? And if we still have time, if there's still interest, I will set up one more layer on if these things are trainable. Is there a way I can just set like en masse if the layers are trainable? You just got to say l.trainable equals false. Can I do that? Keras trainable layer. Trainable layer. Can you do that when you initialize the layer is a question. Core layers, freezing layers. Hey, what do you know? Training layer, freezing the weight, stacking a layer on top, training. Oh, interesting. Stacked autoencoders. Cool. Trivial before by setting layer.params and layer.updates to blank. It has to be done after instantiation, but before adding the layer to the model. Freeze equals. It's not possible after compilation. Interesting. Create a new network, reusing the weights, the previous network, set weights and get weights, stack something on the top, then freeze the layers. Okay. All right. Somebody's got a thing. Need to recompile, rebuild every time. Oh boy, you can freeze layers swiftly, it's trainable arguments. So that's this thing over here. No, that's this thing over here. Over here. Trainable. No. Ah. Training time. Constraint, constraint, constraint. Constraint, 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 constraint. Oh, That is an irritation. Still got a minute left. This law says leave something to be desired so far. It's not quite getting where we want it to be. We'll see. Ultimately, like even if this is twice as fast, that might not be worth it for the actual model training purposes. It might just make more sense to do the larger model that actually can do things. I might just have to, after every one of these models I instantiate, say like x dot trainable equals false, or whatever. Like, can I get away with this whole business being x dot trainable false? I don't know. I don't know if that works in a graph context in Keras. If at this point in the model, if I just said x.trainable equals false, what would happen? We're going to find out in a second. See if that's even something you can do. See what is and is not trainable. Oh, it's so okay. Oh yeah, see that's got some trouble. Definitely got some trouble there. Of course, that is in one epoch. That doesn't necessarily mean anything. I want to see what happens if I say that's not trainable. If that's something I can even do, if I'm using that the right way. Figuring out how to use the tools is half the battle, as they say. Okay. Ready to do this? Didn't yell at me. Alright, that's fine. Let's see. About the same time anyway. Let's see if the loss is just as bad. In theory, the loss should be just strictly worse. Right, because I'm giving the model less freedom about what to do here. I'm saying, no, you can only fiddle with these dense layers. That's the only tool you get to have in your arsenal. This might actually be improving. But there's less things I have to worry about, so I don't know. We'll see. We got another 3 minutes here. So if there are any questions from the audience about transfer learning or anything like that, now's a good time to ask, or other stuff related to Keras, future videos you might want to see, do feel free to lob those questions my way. Today is sort of a more just like figuring out how the code works when I understand the concept, where there's definitely other videos where I understand the code and I'm struggling just getting the concept straight. But today actually worked out reasonably well. What is this? GPU, yeah, that's usual stuff. I wonder if there's another. What's in the examples of Keras? There's a lot, but anti-rectifier, deep dreams. Is there more transfer? Oh, they have a neural style transfer. That's a super good one. I'm gonna be borrowing this later to do some cool work. If you haven't seen neural style transfer stuff, definitely check it out. Definitely check it out. I hope to check that out on stream at some point. That takes a little bit of time and processing power, so it's not gonna be something I want to do all the time. This loss is improving, not super improving. Oh, you know what I can do? I don't really care if it does better or worse, or whatever. M.get weights. Oh, I didn't set my W again. Curses. But I can see if that equals all W0. And the answer is no. So it is training again. It is training those layers still. So whatever I did doesn't actually... Is that where I want that? Right there? I don't know. Just more everywhere. Yes. Let's try this one more time. One more time. It's about time. There we go. List index out of range. That's fine. Okay, we're just going to train this briefly, just to see if I'm getting the training correct or not. That's the only goal there ever is. Get the model working, doing something. Who cares what it's doing? Just something. Anything. Once the model is doing something, then you can iterate. And you just keep iterating until you make the model better. Which is sort of like training in epics. You keep running until it gets better. Well, you, the machine learning engineer, keeps fiddling with your model until it's better. No matter how automated your system is, that's essentially what you're going to be doing. You look for better ideas, you scope out things, you are yourself building a better model of the model. Alright, that's fine. And then I want to know m.get weights. Get weights 0. So the first layer looks like this. Whereas all W0 looks like that. And those are different. Why? Why? Oh, maybe because I need my silly fire modules is what the problem is here. So let me slap some of this down. Left that trainable equals false. Slap that down. Alright, that trainable equals false. I put way too many of these on here. Let's do a new fire module then. And of course that's going to mess with my other model, but whatever. That's fine. Everything is fine. I need to get a new model. Yes, there we go. Okay. Just train this briefly, let it go, crank just for a second. And that will probably be the end of this particular model. Okay, it's doing something, something's happening, things are happening. It's looked at, maybe 1,000 things just to make sure it does something. Yeah, okay, that's fine. So look at the first one. Those I can tell on site that those are different. You see that difference? So it's not obeying this trainable business. So that is something that we will have to sort out. And can I do that in the next 5 minutes is the question. So we look at their example. All they do is they say whatever in feature layer. And feature layer is the activation, the convolution, the pooling, everything. And they set it trainable after they make the model. Is that what I have to do? Maybe that's what I have to do. Set them trainable later. Oh, that's not, wrong one. Here we go. Get rid of that, and that, and that, and that. Okay. Because what if you... Oh. No, it doesn't matter. It's not obeying that, right? Anyway. Actually, I want to see how big this model is. So less than 400,000 parameters. And again, most of those, at this point, after you're merging in the stuff from the convolutions. That's where most of it is coming in. Because you got these 36 going into these 32 things. That's the big chunk of it right there. Alright, so that's good to know. So I could speed the model up considerably by reducing the size of this dense layer. I'm almost certain. Like if I cut that in half, I'd save myself a lot of headache. But then I'm losing a lot of the predictive power of my model, perhaps. So maybe I don't want to do that. What are the options here? Mother border. There's a trainable. Oh. M.trainable. Oh, true. Oh, no. Trainable weights. What are the trainable weights? Aha! How do I change the trainable weights? What if I say m.trainable weights equals m.trainable weights of -6 to the end? Can't set attribute. I didn't realize that was an attribute that I couldn't set. Well, I did already compile this function, so that could be part of it. In fact, that is part of the problem. Let me rip that out. Alright, so let's run this one more time. Let me just redo the fire module this time. Redo that. And now I'm up against the wall here. Running out of time. We're gonna make it though. Here we go. Oh, down here. There it is. M.trainable weights. And the question is, can I just say, hey? Can't do that. No, man. Like, are those the actual layers themselves, though? Trainable weights is 0. What kind of thing is this here? That's some kind of funky variable. If I say L equals that, and I say L dot, is L dot trainable in here? No. Let's transfer. This is funky Keras stuff we're dealing with now. Nah, we're no longer in the Keras universe. Or sorry, it's funky Theano stuff. So you're down in the details here. M dot. What is this? That's just true false. M dot non-trainable weights. Nothing. Why can't I set that though? Property. That's an irritation. M dot no. Make predict test. Yeah, Alright, so I think we're gonna have to call it there. So we have essential transfer learning working using the SqueezeNet model. It remains to be seen whether or not that is better than rolling our own model entirely. I suspect at least part of it should be. But we're having a hard time freezing the squeeze net layer weights, so that I don't even want to bother resetting those. I take those as axiomatic that they are what they're supposed to be. It would be nice to be able to freeze those and say, like, no, I trust them. Even though you could change them a little bit too, and that should help the model in theory. But you might just be overfitting. That is always the trade-off. So that's all we got for tonight. We're probably going to look at transfer learning some more next week. Hopefully I'll have done a little bit more stuff outside of the stream. And I think that is all I got for the week. Again, if there's any questions, we got a few minutes here, so you can feel free to lob them my way. But if not, stay safe in the data mines.